Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning all about probability. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. Odds are, right now, you are breathing at least one molecule from Julius Caesar's last breath. They say calculating the probability would give you about a 99% chance of inhaling at least one molecule from the breath of Rome's most famous fallen emperor. But could that really be true? What do you think? We'll find out at the end of the episode. Now for your word of the day. Our word for today is stochastic. That's stochastic. Stochastic is the fancy way mathematicians and scientists describe something that's randomly determined. If a process is stochastic, it means it has a random probability distribution or pattern that may be analyzed statistically but may or may not be predicted precisely. Essentially, it's the bridge between pure chaos and predictable order. The word stochastic comes from the ancient Greek word stochastikos, which means aiming at a target or guessing, derived from stokos, meaning target or mark. In ancient times, it was used to describe someone who was good at pointing toward the truth even when they didn't have all the information. Today, we use it to describe everything from the way the stock market fluctuates to the way subatomic particles move in a lab. Time for your daily high five, our top 5 fun facts about probability. Number 1. I hate to disappoint you, but you're more likely to be struck by lightning than win a major Powerball jackpot. The odds of winning the massive multi-state lottery jackpot are approximately 1 in 292 million. To put that in perspective, the National Weather Service estimates the odds of being struck by lightning in your lifetime are about 1 in 15,300. This means you are technically thousands of times more likely to encounter a stray bolt of electricity from the sky than you are to hold a winning ticket for the record-breaking jackpot. Many people consider playing the lottery a small splurge for a chance at a big payout, and while that's technically true, even with $10 worth of tickets, the probability of winning is still vanishingly small, like 1 in 58 million. But if you regularly invested that same $10 every week in a straightforward index fund, history suggests a much different outcome. Based on the historic average returns, about 7%, there's an extremely high probability that investment would grow to over $53,000 over 30 years. Whereas if you decided to spend $10 a week on Powerball tickets, you would likely win a few smaller jackpots for matching some numbers, but after 30 years, you would likely end up with just about $2,000 or $3,000. Meaning, if you decide to invest in the stock market instead of the lottery, you'll likely come out about $50,000 ahead. Number 2. A perfectly shuffled deck of cards has likely never existed in that exact order before. The number of possible ways to arrange a standard deck of 52 playing cards is a 52 factorial. Now, the way that's calculated is there are 52 possibilities for the first card, times 51 possibilities for the second card, times 50 possibilities for the third card, and so on down the line. When you multiply all of that out, you get a number that's roughly 8 followed by 67 zeros. This number is so incredibly large that if every person on Earth had been shuffling decks of cards every second since the beginning of the universe, we still wouldn't have exhausted all the possible combinations. Every time you give a deck a thorough, truly random shuffle, you are likely holding a sequence of cards that has never been seen before. But here's the part that really melts my brain. Even though the order is unique, if you take two separate, thoroughly shuffled decks and lay them out side by side, there is a roughly 63.2% chance that at least one pair of cards in the same position will be an exact match. This is based on a mathematical concept called derangements. It means that even in a system of nearly infinite chaos, probability dictates that it is actually more likely than not that you'll find a sort of glitch in the matrix where two random decks align perfectly at least once. Number 3. The so-called gambler's fallacy leads our brains to believe that some events are just due or more likely to happen. The gambler's fallacy is the mistaken belief that if an event happens more frequently than normal during a given period, it will happen less frequently in the future. For example, if a coin is flipped and lands on heads 5 times in a row, many people feel certain that tails is due to come up next. In reality, the probability remains 50-50 for every single independent flip, regardless of what happened previously. This psychological quirk occurs because humans have an innate desire to find patterns and fairness in random systems. Our brains want to believe that the universe balances itself out in the short term, but probability just doesn't work like that. This fallacy is responsible for many losses in casinos as players bet against a streak, failing to realize that the dice or the wheel have no idea that they're on a streak. Number 4. It takes surprisingly few people to make a 1 in a million event happen every single day. While a 1 in a million chance sounds like it would almost never happen, with over 8 billion people on Earth, those sort of miraculous events actually happen about 8,000 times a day. This is known as Littlewood's Law, which states that in the course of any person's life, events with a probability of 1 in a million happen at a rate of about 1 per month. Because we're constantly experiencing events every second we are awake, the math suggests that the extraordinary is actually quite ordinary. When you think of it that way, it really shifts how you think about coincidence or luck in daily life. When you hear about someone surviving a bizarre accident or winning a rare prize, it isn't necessarily a defiance of logic, but rather a mathematical certainty given the size of the population. Probability shows us that even the most unlikely scenarios are bound to happen to someone, somewhere, eventually. And our 5th and final fun fact for today: meteorologists use probability of precipitation in a way that most people completely misunderstand. The probability of precipitation is calculated using the formula POP equals C times A. In this equation, C stands for the confidence the forecaster has that the rain will develop somewhere in the area, and A stands for the percentage of the area that will receive measurable rain. To understand this, let's put some numbers in there. Imagine a meteorologist is 80% certain that a storm will form, but they know that the storm is small and will only cover 50% of the county. They would multiply 0.8 times 0.5 to get 0.4, or a 40% probability of precipitation. This means a 40% chance of rain could actually mean it's guaranteed to rain, 100% confidence, but only over 40% of the map. Understanding this math helps you realize that a low percentage doesn't mean no rain, it just means the rain might be very localized. Now for some news you can use. Sometimes people might be faced with a choice after new information is revealed. This one is based on the classic Monty Hall paradox. The famous problem involves a game show where you pick one of three doors. Behind one, there might be a great prize like a car, and behind the others, something silly like a goat. After you pick, the host, who knows where the car is, opens a different door from the one you picked and reveals a goat. He then asks if you want to switch your choice to the last remaining closed door. Now, here's the pro tip based on the math and probabilities. You should always switch. While our brains tell us it's a 50-50 choice between the two doors, math proves that switching actually doubles your chances of winning from 33.3% to 66.6%. It works because your initial door only had a 1 in 3 chance of being right, meaning there was a 2 in 3 chance that the car was behind one of the other doors. When the host clears out one of the losing options for you, that entire 2 in 3 probability gets concentrated into the remaining door. Understanding these kind of expected probabilities can help you beyond just winning at game shows. You want to think critically and question your gut assumptions. Our gut feeling is designed for quick survival, not complex statistics, which is why it often leads us towards biases like the gambler's fallacy or sticking with a lucky choice that isn't actually helping us. By pausing to look at the actual data and questioning your first instinct, you empower yourself to make the best possible choices in everything from finance to daily planning. Probability shows us that while life may be stochastic and random, the person who understands the numbers will probably come out ahead in the long run. Now for the moment you've been waiting for. At the beginning of the episode, I asked if you are currently breathing at least one molecule from Julius Caesar's last breath. Well, believe it or not, that's a fact. To understand it, let's run the numbers. A single breath of air contains about 25 sextillion molecules. That's 25 with 21 zeros behind it. Or we'll say about 2.5 times 10 to the 22nd. The Earth's atmosphere contains about 10 to the 44th. Molecules like nitrogen and argon are incredibly stable and stay in the closed system of our atmosphere for millions of years. Now, in the case of Caesar's breath, that air would spread through the local winds, but weather patterns and jet streams would have all those molecules distributed across the northern hemisphere within about 1 to 3 months. Within a year or two, it would be crossing the equator, and after several centuries, those molecules are more or less evenly distributed across the global atmosphere. Now, if you take that 25 sextillion molecules, let's round that to about 10 to the 22nd, and distribute it across the atmosphere containing 10 to the 44th molecules, the ratio is about 10 to the 22nd divided by 10 to the 44th. That tells us the concentration of molecules from Caesar's breath is 1 in every 10 to the 22nd. Since that concentration is roughly the number of molecules you inhale with every breath, odds are you're currently breathing at least one molecule from Caesar's last breath. In fact, people who have crunched the numbers more thoroughly say you're probably breathing in about 15 molecules from Caesar in every single breath. Now, I hope you enjoyed learning a bit about probabilities with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.